Okay, guys, so chemical reactions, the types of chemical reactions that there are. So, there are millions of different chemical compounds. Okay, you might think there are millions of types of chemical reactions to get those millions of compounds, but that's not true. There are categories of chemical reactions. There's not that many. In inorganic chemistry, which is what we're talking about, there's 5 basic types of chemical reactions. If you go into organic chemistry and biochem, you'll get some different kinds, but we're just concerned with the 5 basic inorganic chemical reactions. And so let's look at the names of those, and then we'll look at them. So then there are 5 of them, just 5 types. So that's all you have to learn. They are combination or synthesis, so those two words are interchangeable. You'll see and hear both: combination reactions, synthesis reactions. Decomposition reactions, combustion, that's burning, so the normal combustion reaction. Single replacement, also called substitution, and I misspelled substitution there, so make sure that you spell substitution correct. And then double replacement, or also called precipitation reactions. So those are the 5 types. I need you to know all of the different ways to call them. So even though there's 5 types, there's 8 possible names there. So combination, this is the same thing as synthesis. Single replacement, the same thing as substitution. And double replacement is sometimes called precipitation. And actually, even I could give you more, because sometimes the words replacement are called displacement. So you could even say single displacement or double displacement. Okay, so 5 types, several possible names for those 5 types. All right, we'll look at them individually. So combination or synthesis reactions first. In a combination reaction, the word itself gives it away. 2 or more elements combine to form a single compound. So things are combining in this combination reaction. And so an example, a generic form, if you will, is element A plus element B would form compound AB. And the subscripts would have to be determined. So the subscripts here, A, X, B, Y, need to be determined. Now, how do you determine the subscripts? Well, you would determine them based upon the ionic charges of A and B. So A would be Y and B would be X. So whatever it is, A is a 3 plus, so that 3 comes down here. B is a 2 negative, that 2 comes down over here. And so the nomenclature chapter is very important in this unit, and getting the correct formulas of your compounds on the right side. All right, and so an example is magnesium combining with sulfur. And so what would our correct formula be here? Well, magnesium and sulfur each are 2s. 2 positive on the magnesium, 2 negative on the sulfur. And so when you crisscross here, you get MgS. And so that's going to be our formula for magnesium sulfide, is MgS. And I did some little animation here in this presentation. And so you have a magnesium, you have a sulfur. They're separate compounds. They're going to end up combining and forming a new compound, MgS, where they are bonded together. Now that's not exactly what it's going to look like, because it's going to be an ionic crystal lattice, but you get the point, the ratio of 1 to 1 there. Another example is iron plus sulfur. Now in this case, since iron is a transition metal, there are many possibilities of what its ionic charge could be. So for you to complete this, I would need to tell you what its ionic charge would be. I believe on this example I've made it a 3 plus. And so if iron is a 3 plus ion and sulfur is a 2 negative ion, then you're going to get Fe2S3. And so that would be your form there. Again, if it's a transitional metal element, then for you to do it, I'm going to have to give you what the ionic charge is going to be. So you look for that. Otherwise, I'm just going to give you something that's not transitional. All right? Balancing this, we're going to need to put a 2 in front of the iron and a 3 in front of the sulfur to get the correct balanced equation. Again, a little animation: 2 irons and 3 sulfurs. They're all going to combine and form an iron sulfide compound. Again, not what it would really look like, but it's just kind of an illustration. Combination or synthesis practice. So let's do a few. So calcium plus nitrogen. So how do you recognize a combination reaction? you're going to be looking at pretty much elements, an element plus an element. If you see that, stick them together. So calcium and nitrogen are going to form calcium nitride. And when you do the calcium, you're going to look up the value of calcium. And so calcium is over here. And that's in the 2 positive column. And nitride is over there, and that's in the 3 negative column. And so we'll get a calcium 2 positive and a nitrogen 3 negative. When you crisscross your charges to get the right formula, you'll get a Ca3N2. So there's your formula. The thing that you're doing here is I'm giving you the left side. You've got to come up with the right side of the equation. That's part of the reactions chapter, is you are predicting the products. And again, we're going to need to balance this. So I'll put a 3 on the calcium to balance that equation out. Potassium reacts with oxygen. All right, so we need the charges of potassium and oxygen so we can put them together. And so potassium is over here in the 1 positive column. And oxygen is over here in the 2 negative column. A lot of these, you guys should know these by now, and I'm sure you do. And so if we look at the potassium 1 positive and the oxygen 2 negative and crisscross those, we get K2O. Not balanced. We have 1 potassium on the left, 2 oxygen on the left, 2 potassium on the right, 1 oxygen on the right. We'll fix the oxygen by putting a 2 in front of it, which changes our potassium to 4. And so we can put a 4 in front of the potassium to balance that equation out. So 4 potassium atoms plus 1 oxygen molecule would make 2 potassium oxide formula units. All right, second kind of reaction is a decomposition reaction. And so decomposition is where things break apart. Decomposing is a breaking apart of things. So a large compound breaks into smaller compounds. That's decomposition reactions. So an example, compound ABC, and there's going to be subscripts on the A and the B and the C, and potentially subscripts on the A, B, C on the right side as well. Break apart. It could break apart into the individual elements. It could break apart into a smaller compound plus another element. It could be A plus B, C. There's lots of combinations here. Just knowing that something breaks into smaller compounds is what a decomposition reaction is. Apart from a few that I'm really just going to ask you to just kind of know what they are, all of our decomposition reactions will break into the individual elements because it's hard for you to predict otherwise. So here's one that I do want you to know. Hydrogen peroxide does not break apart into hydrogen and oxygen. It breaks apart into water and oxygen. I want you to memorize that equation if you have not already done so, because we've talked about it a lot. So if you don't know it, learn it now. That is the reaction for the decomposition of hydrogen peroxide. And that needs to be balanced. So we'll put a 2 on the water and a 2 on the hydrogen peroxide. And here's an example. So 2 H2O2 molecules, and that's kind of what it looks like. The O's are in the middle and the H is on the outside. Those are going to break apart and are going to form 2 waters and an oxygen molecule. And so we'll do that again. I like that one. So 2 water H2O2s breaks apart and forms 2 waters and an oxygen. All right, some practice on those. Again, for our decomposition reactions, when I'm giving you the reactions, you just break them apart. And other than like the one I made you memorize there, hydrogen peroxide, break them into the elements. So phosphorus and oxygen, the phosphorus trioxide will break apart into phosphorus plus oxygen. So the only thing that you got to remember on these is when you break apart into a diatomic element, the oxygen needs a 2 on it. Balance that, we'll put a 3 on that oxygen and a 2 on the PO3. And then we'll come back and put a 2 on the phosphorus. Another example, aluminum nitride. Break it apart into aluminum and nitrogen. So aluminum is just Al. Nitrogen, again, a diatomic element, so make sure there's an N2 there. Balance that, we'll put a 2 on the aluminum nitride, and we'll come back to the right side and put a 2 on the aluminum. And I think one more, manganese sulfide. That'd be a manganese Roman numeral 3 sulfide. We'll break apart into manganese and sulfur. So manganese Mn, sulfur is just S. There's no diatomic elements here. And so we'll just put the elements down, and then we'll put the 2 and the 3 on the right side to balance that out. And so all of the ones that I give you are break apart into the elements apart from the memorization reaction of hydrogen peroxide decomposing into water and oxygen. All right, so we're going to stop there for today, and we're going to do some more later.